This is going to be a continuation of section 3.5 on significant figures, also called significant digits. Last time what you guys did is we went over the rules. These are the rules. And also you can find those rules on this handout as well. That should have been submitted or should be submitted soon. So these tell you all the rules that you should be following for this. And you could then take a look at those significant digits. So for example, for a couple of these, the 2 is significant and the 0 is not significant because it follows the rule that zeros after the decimal are not significant. So the only significant digit is going to be this one, so the answer would be 1. Like manner, this is a significant digit, the 0 before is not, however the 0 is after. That means we measured to that accuracy, so this actually would be 2 significant figures. So that's the work that you're going to be showing for all this. And determine the location of the last significant place by placing a line over it, or you can also circle it. What it's asking is, which of these is the last significant digit? And the answer for this one is going to be the 4. So the zeros before a decimal place are not significant. The zeros in between numbers are significant. So it would be 8, 0, and 4. This would be 3 significant figures. For this one right here, the 3 is significant because it's a non-zero. This is not significant because it's after the decimal and before a number, but the zeros after the number, after decimal, are significant. So the last one would be here. That's the work that you show for that. So we're going to continue on with section 3.5, so we don't need a new page. And we're going to be on item number 2, because now we need to apply these rules for significant figures to multiplication, division, and addition and subtraction. So we're first going to take a look at addition and subtraction. So item number 2, we're going to be adding or we're going to be subtracting. It's the same rules for both. What's interesting is with significant figures with addition and subtraction, you don't use significant figures. So we don't use, and I'm going to abbreviate significant figures as sig figs. Let me give an example. Let's say you have a measurement of 1.37 and we are adding to that 2.14 and 3. Let's say we're collecting some class data and 2 people use the scales that measure to the hundredths right here, and 1 person used a different scale that just measured to the single digits. If we add these on a calculator, and for this you're able to use your calculator, you just show your work like this and what the answer is. So let's go ahead and add this on the calculator. 1.37 plus 2.14 plus 3 would give me 6.51. So we have 6.51. However, in significant figures, that is not the correct answer. So what we need to do is we need to use the least precise measure. That's the big key for adding and subtracting. You use the least precise measure. These go to the hundredths. Those are very, very precise. That gives us a lot of information. This scale only went to the ones. So we need to use the least precise. The least precise is going to be right here. So what we have to do is we have to round to the ones place. Now we're not always going to round to the ones place. We're rounding to the ones place because our least precise measure is in the ones place. So we want our answer to be a single digit, 6.51, and we're going to need to use the next digit to either round up or round down. So we're going to round, in this case we're going to be rounding up. So we round up in this case. And so the answer for this is going to be 7. That's my answer. I can't get any more precise than the ones place. Let's do another one. Let's say we have 22.1, 11.23, and 1.046. Okay, we need our calculators for this, so let's clear this out. 22.1 plus 11.23 plus 1.046. My answer comes out to be 34.376. Okay, this one goes to the tenths place. This value goes to the hundredths place. This goes to the thousandths place. But I have to follow the rule. I'm going to use the least precise measure. Which of these is the least precise measure? It's this one. And what place value is this right here? This is the tenths place. So what I have to do for this is I have to round to the tenths. Round to the tenths place. So the tenths place value is this right here, 34.376. It's the 3. So I have to use the number after that to either round up or round down. In this case, I would round up, and rounding up would give me an answer. The answer is going to be 34.4. That's the rule for addition or subtraction. Let's go on to multiplication and division. If you're multiplying or dividing something, this is when we do use the significant figures. And when you multiply or divide, you use the least number of significant figures. Let's go through two different examples. If I have 7.31 times 1.3. Okay, let's just go ahead and do this on the calculator. This is why we need calculators. 7.31 times 1.3. Answer is 9.503. 9.503. So after doing your calculator, we need to go to the rule. Use the least number of significant figures. How many does this have? Well, they're all non-zeros, so it's 1, 2, and 3. I have 3 significant figures here. How many do I have here? I have 1, and I have 2 significant figures. This is really important why we need to know our significant figures from our significant figure rules. So what's the least number, 3 or 2? The answer is 2. Therefore, my answer must be in 2 digits. And I'll have to use the next one to either round up or round down. In this case, I would round down. So my answer would be 9.5. Not because it's to the tenths place, but because it's actually 2 significant figures. Let's do another one, and this will be 0.004030 divided by 1.34. Okay, let's plug this on the calculator. 0.004030 divided by 1.34. Okay, that gives me a big answer there. This gives me 0.003074,627. Now, it would be horrible if every student wrote that answer for this division problem, which is why we're using significant figures, because many people would write this maybe with 2 or 3 or 4, but we actually have to follow the rules for this. So again, we're going to be using the least number of significant digits. This one's the easier one, 1, 2, 3. This is 3 right here because they're all non-zeros, but What is this? 1, 2, 3, 4, 5. We have 6 numbers. We have 4 of them are zeros. So we have to go back to our rules. Well, I know I at least have 1, 2 there because those are non-zeros. There's a rule that also states that zeros in between non-zeros will be significant. So I know I have 3. Question is, are these 2 significant? Is this last one significant? Going to the rules, you'll see that the zeros after the decimal and before a number are not significant. Those are not significant. So this is just in determining the number of significant digits. So zeros after a number after decimal, they are significant. So I actually have 1, 2, 3, 4 significant figures. Okay, so now I have to follow the rule. Use the least number, which is less, 3 or 4. It's 3. So my answer needs to be in 3 digits, 1, 2, 3. Then I need to use this to either round up or round down. 7 is past the 5 mark, so I'm going to round up. So in this case, my answer is 0.00301. Please look for the handout, continuation of 3.9.